wanted to show you a project that I've been working on. It's a tool to be able to find things in satellite imagery. It's a process that I've used a lot in the past, but it's required multiple tools, a lot of coding, and really slow iteration. This makes it all easy in one package. We're going to do a demo of finding mining in the Amazon. I'm kind of familiar with this problem, so it's a good reference. We'll call our project mining, select a chip size of 48 by 48 pixels, and have Sentinel-2 as a data source. We'll create the project and get started. There are three main steps in this process: labeling data, training a network, and deploying that network and evaluating the results. We'll start by labeling data. Labeling data for the appropriate time period is very important. Mining moves very quickly, for example. You might label something that seems like a positive in high-resolution base map imagery, but is actually a dormant mine grown over by the forest. We'll start by selecting our time period, which will select a year duration from the year 2024. This will make a year-long cloud-masked composite. Each point that we label will be associated with a time period for which that data is extracted. To label a point, left-click for a positive sample, and you'll see the data is extracted and displayed on the map. Right-click to label negative samples. I'll go through and label about 30 samples of each class, and we'll come back to training a model. I'm speeding up this process by about 5x, but you can see that it's pretty efficient still. When labeling points, I'm trying to select things that are clearly mines and things that are kind of an interesting negative class. For example, portions of the river that don't have mines. This type of labeling process will be different for every type of problem that you have, but I like to think about it like a teacher. I'm trying to give concrete examples of the behavior that I want to see and good examples of tricky cases. Now that we have about 30 cases of mines and not mines, it's time to train a network. We'll go over to the Train Model tab, and here you have some options for your parameters. For now, we'll keep it at the defaults. We'll call this model 1.0, and then keep a batch size of 4 and 64 epochs. The model will train, and given the very small amount of data, I expect this to take about 15 to 20 seconds. Great, so now we have a trained model, and we can give it a test. We'll go over to the Deploy Model section, and we'll find a region to test our model. So by default, the model will be deployed over the whole area that is visible on your map display. Here you can see that it would process about 7 million pixels. Let's find an interesting area that we haven't labeled too much of and give it a try. This looks pretty good. We'll hit deploy and let it run. The time it takes to run this process depends on how much area you're processing. For this region, it takes about a minute and a half. It looks like the model did a pretty good job. We can now go through the process of labeling areas where the model did well or did poorly, training another model, and giving it another go. Let me know what you think of this tool. I think it could be helpful for journalists and other geospatial people who don't have as much experience with coding, extracting data, and training models.